Hi, this is Miss Oliva, and I'm going to be doing a video that would help with 1.4. It's on linear graphs and equations. And again, feel free to pause at any time to try some of this or rewind it, whatever is helpful to learn what I'm teaching. So I'm going to go a little fast again. Okay, so slopes and equations. First, what is slope? Slope is basically how the steepness of a line, right? The larger the slope, the steeper the line. We also call it rise over run because slopes are typically fractions and the top number is telling you how much it's going up or down, and the bottom number is teaching you how much it's going to the right. So if it's going up, it will be a positive slope, and if it's going down, it will be a negative slope. And as far as the letter for slope, you will typically see M used for slope, and I'm not sure exactly how they got that, but that's slope. Okay, so if you have a graph, you don't need a fancy formula to find the slope. You simply need to pick 2 points, any 2 points on the graph that you can clearly see, and just make sure you're always going from left to right. So I'm definitely going to start with this point, and I'm first going to decide how much up or down I would need to go to get to that point. So in this case, it would be up 4. So my slope has a 4 on the top and to the right, 3. So the slope of this graph is 4/3, which means if I went up 4/3 again, I would hit the graph again, right? Because the graph goes forever. So let's try it again. What is the slope of this graph? Well, I'm going to pick these 2 points. Again, any points. It doesn't have to be the x and the y-intercept. That's just the easiest way for this one. I definitely am starting from the left. So since I'm starting with the left, I have to go down 1. So this will be a negative slope. Then I'm going to go to the right 3. So that is how you can always just count between 2 points to find the slope. Now, these 2 graphs I call special graphs because we do everything with them totally differently. You do not need to pick 2 points and count because it gets a little confusing. You just have to learn and memorize that anytime you have a line that's straight up and down, which we call a vertical line, the slope is always undefined. That's it. It doesn't have a number. You just say undefined. The reason why is if you went through the work, you would have ended up getting 1 number on top and a 0 on the bottom. And we never want zeros on the bottom. So this one that goes side to side, which we call a horizontal line, always has a slope of 0. So it's best to just really learn that these all go together, these all go together, so you don't accidentally try to do it some other way and get confused. Now, if we don't have a graph, we will need this fancy looking formula, but it's not as complicated as it looks because the little 2's and the 1's are basically just telling you whatever order you choose to do the top. So when you have your 2 points, if you start with 6 and say 6 minus 4 on top, this is just trying to explain that you need to start with that same point when you go to do the x's on the bottom. So if I choose to start with the 6, that's fine, but I have to now start with the -1 since these came from the same point. That's all that is saying. Otherwise, you can just think of it as y minus y and x minus x. Just be careful with the negatives. 6 minus 4 is 2. -1 minus 3 is like -1 plus a -3, so it's -4. And then always try to reduce if you can. So what this means is if I were graphing this, I would start with a point and then I would go down 1, right 2, down 1, right 2. So now let's try one with fractions, just because that always is harder. So if I say 3/5 minus 1/2 on top, I would have to start with that -4 on the bottom. The bottom isn't too bad, but the top is kind of a pain. So I'm going to come over here and review a little of fractions. Remember, you cannot add or subtract fractions unless the denominators match. So I'm going to multiply this one by 2, which means I do the same thing on top, and this one by 5. So I get 1/10 on top and -7 on the bottom. But again, that looks weird. So what is that really? It's really the top number divided by the bottom number, right? That's what this means. This is being divided by this. And with fractions, that really means you're going to multiply by the reciprocal. So this is a lot of fraction rules I'm trying to remind you of, but remember you can do the fraction part in your calculator. I just want you to at least have seen some of this because it will come up later, okay? All right, slope-intercept form. There are different forms that equations can be written, especially when we're talking about lines, which is what this part's all about. One of the ways is slope-intercept form, which is this: y equals mx plus b. We've already discussed that m is the slope, but now b is a special point. It is the y-intercept. So it is the spot where the graph is going to cross the y-intercept. Okay? So for the first one, if this was my equation, it would mean that my slope is 2. But remember I said we like the slope to be a fraction because remember the top means one thing and the bottom means another thing. So if our slope is just 2, I'm going to rewrite it 2/1. And then if my b is 3, that means on this line, we're going to cross it at 3. So that's the first thing I do is put a point there. Now, since I know my slope, I'm going to just start at that point and do what the slope is telling me to do. So 2/1 means up 2/1. And you can do it more than once if you would like to. And you can even go the other way. But basically, we have a line that looks something like this. Okay, so let's do that again. This is my slope, and it's a fraction, so that's good. But I'm going to start with this, which I don't want to be a fraction, so I like that it's not, because that's just telling me the number where I cross the y-axis. So I put my first point at 2. Now, since the slope is negative, it's telling me to go down 1, but still to the right. So if your slope's positive, you go up and right. If your slope is negative, you go down and right. So down 1, right 4. If you want to do it again, you can. But basically, we have some kind of line like this. And then finally, this one, I cannot start right now because it's not in any special form. So I'm going to change it into slope-intercept form, which I can do pretty easily because all it means is get that y by itself and you should be good. So if I want the y by itself, I'm moving this entire 3x. So I'm not dividing. I would divide if I only wanted to move the 3. But if I'm moving 3x, I will subtract. Do not actually do 5 minus 3 because you can't. If the 5 doesn't have an x, you can't do the subtraction. So I'm just going to write 5 minus 3x. Now, this is in a different order than we had before, so be careful. Whatever number's with the x, no matter what order it is, that is your slope. So the 5 in this case is the b, which is the y-intercept. So I'm going to maybe just make a note of that my slope is -3. So see, I wrote it again, -3/1. And my y-intercept is 5. So I'm going to start by putting a point at 5. And then I'm going to use my slope, which is negative, to go down 3 and right 1. And you can do that again. So connect, and you're good. Okay, so if it's not in the right form, move things around to get it in the form you like, and then it should be fine. Okay, again, we have special lines. So if you do not see a y at all, you're definitely not going to be trying to do slope-intercept form. Okay, there's a special way you can graph this one. And if you only see a y, same thing. So basically, if you only see one of the variables, no matter what it is, you can think of this as a special line, which means you're going to do it totally differently. So what does x equal 3 mean? It means, and you are not going to have to do this every time, but I'm just going to show it once. It means that no matter what, the x is always going to be 3. So there's no way that would ever change, right? So what's the y then? It means the y could be anything. So y could be 0, y could be -1, y could be 2. I'm just making up some random points so I can graph these points and see what this line looks like. But you should never have to do that again if you understand. So 3, 0 is here. 3, -1 is here. 3, 2 is here. Do you see what's happening? Even if I did 20 more points, they would all be on top of these points, right? Above or below. So we have a vertical line. That is always going to happen if it's just x equaling a number. It will always be just a vertical line where that x is that number. So if instead of x equals 3, it was like x equals -1, it'd be over here, a straight line where all the x's would be -1. Okay, so remember, we call this a vertical line because that's what it is. And just to remind you, the slope of a vertical line is always undefined. So that's one special line. The other special line is if there's only a y. Well, you could probably guess that this is going to be the opposite type. But again, just to show you why it works, in this case, all we know is the y. So y is always going to be -1 no matter what the x is. So again, I could try to just make up a few to make sure I understand what this is going to look like. So -3, -1 would be here. 0, -1 would be here. And 1, -1 would be here. So yes, it is the opposite. It is the horizontal line. And that means my slope, if they ask me, I know is 0 because the slope is always 0 for a horizontal line. Okay, so number 3 looks totally different, right? But I notice right away that there's only one letter. So this must be a special line. And since that letter is x, it must look like this. But I'm not quite ready to draw it because right now maybe I would draw it at 4. So still get that x all by itself before you start. So now I see that the x's are always 2, and that would be anywhere above or below this. Again, if you're iffy on this at first, pick a few points and test it out. Then you won't have to guess. So this same idea, I noticed that I only have a y, so I'm not doing this with slope intercept. I'm just going to get that y by itself, and then I know what it looks like. So y should be -5. So I go to -5, and it must be a horizontal line there. Just to keep reminding you, the slope of this one is undefined, and the slope of this one is 0. Okay, this would be a good chance to pause and maybe try 5 and 6 by yourself and then watch me do it. So I'm going to go ahead, but pause if you want to try it first. I'm going to add the 4. I'm going to divide by 6. X equals 1 is my equation. I know that's a special line, and it's a special line that looks like this, where x equals 1. And again, if they asked for the slope, it's definitely undefined. One more, I'm going to subtract 1. I'm going to divide by 3. So y equals 2. So my line is going to be a horizontal line where the y's are all equal to 2. And the slope is 0. So now it's asking, what would be the slope of any line that is parallel to the y-axis? Well, don't rush. Make sure you understand that this is the x-axis. This is the y-axis. So for it to be parallel to the y-axis, it actually has to be this one, which is the vertical line, which means the slope is undefined. So again, if you want to pause and think about this one, then you can see if you did it right. Since this is the x-axis, any line parallel to that would have to be horizontal, and so the slope would be 0. So it just takes some practice to get used to these, but then these should be the easiest type. You see only an x, you know it's vertical, put it where it goes, you know the slope. Okay. If it is asking me for the slope and the y-intercept, and they give it to me in this type of form, I know this isn't the form where I can easily answer that. So again, I'm just going to move some stuff around first. I'm trying to get that y all by itself. So first, I'm going to move this minus 3x by adding it to both sides. I can't actually add that, so do not make that a 9. And then now my last step is to divide everything you see by 2. So the 3 is by itself. So that is my y-intercept. I'll get to that in a second. The 3 over 2 is with the x, so that is my slope, and I'm happy that it's a fraction. Now, the y-intercept is 3. If you wrote 3, that's not wrong, but if it's specifically asking for an ordered pair, be careful and think about what this point would actually be if we want to write the whole point with the x and the y, right? Because we know 3 is the y-intercept, so we know we're hitting there. What would that be as a point? It would actually be 0, 3. Okay? And now if they wanted me to continue graphing this, I would just start from that y-intercept, and I would go up 3, right 2. There's my line. Okay. So this one, same idea. We don't have to graph it, but can you tell me what the slope and the y-intercept is, which basically means getting that y by itself. So I would pause and try, and then see how you did. So it's just doing the same thing we did, but with decimals. That always makes it feel a little more uncomfortable. Oh, I can't put these together. I almost did. Oh, there was no subtracting needed to be done there. And then we're going to now divide everything by 0.07. So my new equation is y equals 4 minus 4 over 7x. So see if you're able to get that. If you did this in your calculator and you got a weird fraction or a weird decimal, remember you can change it to a fraction pretty easily. So, okay, so I got my calculator so I can show you. So if you were doing 0.04 divided by 0.07, you would get this decimal. That's not even a nice decimal. It goes on forever, most likely. So I would like to ask my calculator to change it to a fraction to see if it's a nice fraction. So most calculators, and yours might be different, but remember you're not supposed to be using a graphing calculator, only a scientific one similar to this. In my calculator, it's above here, but usually you can find it somewhere where it has an F and a D with arrows. What that is, so you see above mine, that's a button that will change from a fraction to a decimal or vice versa. So since we have a decimal, if I hit, and anything in green means you have to hit the second button first. So second and that button, and that means 4 over 7. So it's a nice fraction. So that's where I got the 4 over 7. So that means my slope is negative 4/7, and my y-intercept is 4. But let's just say they asked for the ordered pair again. Make sure you get that that means 0, 4. Okay. All right. Telling if a function is linear, constant, or neither. So linear means any kind of line. So it could be going up, it could be going down, whatever. Constant means that it's just going straight across. So that would be the horizontal lines, right? And neither would be anything else. So First, I'm giving you some examples of linear. So anything where basically you can see that there's a y and an x and nothing odd happening, it's going to be a line. So this would be a line. This would be a line, right? The fraction doesn't bother us. That's just the slope. This would be the line. Keep in mind that this is in slope-intercept form. There's just no number here, right? Which means there's like an imaginary zero. So if you were to graph this, you would just start at 0, and then because the slope is 3 or 3 over 1, up 3 over 1. So it is just a normal line. It just happens to have 0 for the y-intercept. And then this one does look weird, but x over 3 and g of x is just, this is just another way to write y. It's just a fancier way to write y because now I can call this line f and this line g instead of them both being y, which is confusing. So I want you to know that x over 3 is the same thing as 1/3 times x. So nothing weird there. Okay, for a constant, since it's horizontal, it has to be something like y equals 5. Just don't forget that f of x is also like a y, and h of x or anything like that is also a y. So all three of these would be constant. If I graphed them, they would just be straight horizontal lines. So here are some examples of neither, and the key to it being neither is the x. So one thing that makes it not a line is if x has some kind of power here that's bigger than 1. So it could be a 2, a 3, a 5. All those would not be lines. And then this is bad. So make sure you look at the difference between up here, x over 3, which was fine, and here, 3 over x, which is not fine. Remember that if x is in the bottom, that is the same as it being like a -1 power, right? So again, it's a weird power. So basically, we always want the x's to have a power of 1 for it to just be linear. And same thing here, square root of x obviously looks different, but again, you can rewrite that as x to the 1/2. So another exponent that is different. Okay, so all these are examples of the neithers. All right, remember I said there was multiple forms to see a line. Here's another one, point slope form, which is usually a form used if you don't have your y-intercept, but you just have like a random point, okay? Again, it looks really fancy, but all it means is this is where you're going to put your slope, and the x1 and the y1 are just the x and the y of the point that you have. Okay, so x will stay an x, y will stay a y, but the x1 and the y1 is where you're going to put your point. So if I wanted to write this, I would say y minus the y. So be careful, that means there's another negative there, and we'll fix that in a second, equals the slope times x minus the x. So if it asks you for point slope, you would stop right there. This is point slope. But if it wanted y-intercept at the end of this, we're going to do a little bit of math to make it look the way we want. So the first thing I'm going to do is change minus a negative to plus. And then here I'm going to distribute this, which isn't as bad as it looks because -3/5 times x is just that. And -3/5 times 0 is 0. So I'm just not going to write that. So I'm almost done because all I need to do now is subtract 9, which gives me -3 over 5x minus 9. And if they asked me to graph this, that would not be too bad. I would start at -9, put a point, and then I would go down 3, right 5, to put another point. Okay? So again, you could pause and try this one, and then see how you do. Y minus the y equals the slope, x minus the x. Distribute the 5, and now subtract the 10, 5x minus 15. Okay? Okay, last thing, average rate of change. is just a fancy kind of way to say slope. It just means we're probably talking about something more real. But in this case, here's the fancy formula. But keep in mind that f of b just means like a y value when we plugged in the b, and f of a is another y value. So you see that that's really subtracting two y values, and the b and the a are like the x's. So it's very similar to just finding the slope of 2 points. It's just that we don't have the 2 points. We have to find them. So here's how a question would look. Find the average rate of change for h of x equals 3x plus 5. So that's my equation on the interval 2 to 5. So they're giving you two different x values there. So they just call them a and b. Okay, so using this formula, f of b minus f of a over b minus a, well, the bottom part's easy. B minus A, right? That's easy. So all I have to do on top is find what do I get when I plug in the 5 to the equation. So technically, instead of F, it should have been H in this problem, sorry. H of B minus H of A, since our equation was called H. Sorry. So plug in the 5 and see what you get. 3 times 5 plus 1, 15 plus 1 is 16. So when I plugged in the 5, I got 16. So you see, that's just like my y value. This was the x. When I plugged it in, I got 16. Minus, let's see what I get when I plug in my 2. So remember, it's not -2 I'm plugging in, it's just 2. Okay, so 3 times 2 plus 1, 7. So I need to subtract on top and subtract on the bottom. I get a 9 on top, and I get a 4 on the bottom. I don't remember what form they'd want, but if they're okay with a fraction, you could stop there. If not, you could put that in your calculator and give them a decimal. Okay, so let's try it again. In this case, here's my equation. Here's my A, here's my B. So we're really finding M of B minus M of A over B minus A. So again, the bottom is the easy part. The top is what we get when we plug these things in. So plugging in 33, I would get 33 minus 3, so the square root of 30, minus plugging in the 25, I get the square root of 22. And so I'm just going to put that in my calculator since it's obviously not going to be super nice numbers. So I'm going to do the square root of 30 minus the square root of 22. I'm going to hit enter, and then I'm going to divide that by 8. That's what this really is. 33 minus 25 is 8. Okay, I get an answer that's not nice. I'm going to try to change it to a fraction, but it doesn't work. So most likely they are going to tell you what to round to for a problem like this. So let's just say it said round to the nearest 100. So that would be this spot, right? If I'm rounding to the hundredths, I need to look at the number next to it to decide if I need to round it up, and I do. Since it's a 9, if I round it up, it would become a 0, and we would carry the 1. So my final answer would be 0.1. Okay? And now for the very last question. Just because it's different, I wanted you to see this one time. It's asking me to not do any algebra or math over here. It's just saying, can you use the graph of these two things to answer these questions? So if we look carefully, we should be able to figure out which is which, right? This one should be hitting the 1 and should go up 2 over 3. So this looks like it's the 2/3 x plus 1, just to label them so we don't have to keep trying to remember. And let's see if this one makes sense for the other one. Does this one hit a -2 and looks like it's going down 1 over 3? Yes. So this is the -1/3 x minus 2. Okay, so the first question is just asking us, where do these two things equal each other? And since there's only x's in this problem, I'm just answering it by explaining the x. So these two lines hit each other. They're equal right here. This is the point, -3, -1. But I only care about the x in this type of question because that's the only thing that's in there. So my answer for this one would be that x equals -3. These two different equations, these two different lines are the same when x equals -3. Okay? Now it wants to know what x's are going to make this line less than this line. And less than means under. Okay? So if this is where they're equal, this is probably where it switches, right? Notice on the left of my dotted line, the orange one is on top. So the orange one is greater than the black. And on this side, it's the black that is greater than the orange. So which do we care about right now? We want the 2/3 x minus 1 to be less than this. So we want the black line to be under the orange. That happens over here. So that happens when x isn't equal to -3, but everywhere to the left, right? So x is less than the -3. So I'm not saying less than because this said less than, because it could have easily been switched. I'm saying less than because it's to the left of -3 that the black line is under the orange, and that's what we were looking for. So now for the next one, it wants where the black line is greater than or equal to, so above or equal to the other one. So that would be everywhere to the right. But since it also says equal, we also want the -3 as part of our answer. So basically we want -3 and every x that's to the right of -3. So how do we write that? X is greater than or equal to -3. So that is it. Feel free to text or email if you have any questions.